You are looking at a landscape that holds roughly 70% of all the fresh water on Earth. There is so much ice packed into this single location that if it melted entirely, global sea levels would rise by 60 meters. Yet, by the standards of meteorology, this massive concentration of frozen water is the largest desert on the planet. This is Antarctica, a continent defined by a freezing environment and extreme isolation. To find a larger one, you would have to look beyond our world. The Sahara, which we typically imagine as the largest desert, spans about 9.2 million square kilometers. Antarctica dwarfs it, covering 14.2 million square kilometers. The reason it earns this classification has nothing to do with sand or heat. A desert is defined by a lack of precipitation. Any region that receives less than 250 millimeters, or about 10 inches, of rain, snow, mist, or fog a year is a desert. Temperature is not part of the definition. Deserts are a category of dry places, meaning our traditional image of rolling sand dunes is only one part of the story. To understand why Antarctica is so dry, we have to travel inland. The coastal edges of the continent receive a moderate amount of snowfall, averaging over 200 millimeters a year. But as you move toward the center, that moisture vanishes. This cross-section map shows that drop-off. You can see the coastal precipitation resting around 200 millimeters, but as the chart moves into the high interior plateau, the numbers plummet. The air delivers only 25 to 50 millimeters of water-equivalent precipitation annually. Near the geographic pole, the average is roughly 10 millimeters a year. The first cause for this dryness is the cold. As air temperatures drop to around minus 50 degrees Celsius, the air loses its capacity to hold water vapor. There is very little moisture available to fall as snow in the first place. Second, the ice sheet sits high above the sea. The average elevation of Antarctica is roughly 2,300 meters, pushing the surface of the continent into thinner, colder air, which drives the humidity down further. The physical geography of the continent itself acts as a barrier to weather, making significant snowfall mathematically unlikely. There is a third factor, a persistent system of high atmospheric pressure hovering over the interior. This high-pressure system pushes moisture-bearing weather away before it can reach the center of the continent. This combination of forces produces the McMurdo Dry Valleys. High winds whip through these valleys, triggering sublimation, a process where ice turns directly into vapor without melting. This strips away moisture, leaving the rock bare. These valleys are so dry that scientists use them as a primary stand-in for Mars when testing new equipment. Earth's largest desert is so extreme that its edges mirror the landscape of another planet. If so little snow falls here, where did 14.2 million square kilometers of ice come from? The answer is in what happens to the tiny amount of snow that does arrive. Because it is too cold and dry for the snow to melt and run off into the ocean, it simply stays. Over hundreds of thousands of years, those sparse snowflakes stack up, getting buried and physically compressing into solid, dense blue ice under their own weight. The Antarctic ice sheet is not recent weather. It is an ancient bank account where deposits are made over millennia and almost nothing is withdrawn. This allows scientists to extract ice cores from the glacier. Because the ice has piled up steadily, these cores contain a record of the atmosphere stretching back through time. The same lack of moisture that defines the desert prevents the ice from melting or running off, keeping it stable long enough to preserve a record of the planet's past. A desert is defined by the balance of what arrives, not how much water is present on the ground. This rule also makes the Arctic, spanning parts of Canada, Greenland, and Russia, the second largest desert in the world. We expect deserts to be hot and filled with dunes, yet the two driest large regions on Earth are frozen solid. The places holding the vast majority of our world's fresh water are simultaneously the places most starved of it.